Hello, we have to talk again bioremediation in environmental microbiology and public health. So we are talking here about bioremediation. As in our previous session, we talked that bioremediation is process of using of microorganisms for the cleaning of the environment. So use of microorganisms due to their extraordinary metabolic diversity and extraordinary metabolic activity, microbes have potential to decompose, to degrade the pollutants or convert them into less harmful or less toxic forms by denaturing or by decomposing. So here we are going to talk again types of pollutants. If you will see types of pollutants, there are major are three types of pollutants. Number one, organic pollutants, which has been catabolized naturally occurring pollutants, which has been produced by nature, which has been produced by living organisms. The nature of those pollutants is organic in nature. Those are called organic pollutants. So about these pollutants, we know this thing very well that these pollutants are produced naturally, growing naturally, dying naturally, and natural microbial communities which are present in that particular environment have ability to decompose these pollutants properly. Suppose if you will take example of the forest where all the trees which are fallen down gradually are going to be decomposed and they are going to be mixed into the soil by decomposition of microbial communities. Because microorganisms which are growing over there from uh, unknown time duration, they have got this ability and the potential to produce certain enzymes which can decompose the wood material cellulose into elemental form. And if you will see another form of pollutant is xenobiotic. Xenobiotic are those pollutants or substances which are foreign to an entire biological system. Or in other words, we can say artificial substances which did not exist in nature before their synthesis by humans. These are the another type of pollutants which are man-made pollutants. Either it has been synthesized by chemical reaction or by any other means this has been produced by human beings and their nature is not natural. Those has been synthesized. Their arrangement of the uh, items, particles is not natural. And such type of pollutants which has been made by human beings are foreign substance for this nature globe. Substances foreign to an entire biological system are man-made pollutants, and these pollutants are very severe and very toxic and very harmful for the environment. Because why these are harmful? Because microbial communities are not adjacent, not adapted to decompose such type of pollutants which are new for them. So microbial communities have no mechanism to produce certain enzymes to decompose such new compounds which has been introduced by human activities or has been produced by humans. So these are called xenobiotics, and most of the xenobiotic pollutants are recalcitrant, which are difficult to degrade in environment because microbial populations and microbial communities are not adapted, have not familiar to decompose such type of pollutants. And number three pollutant, metals from ore extraction and manufacture. Suppose people are mining and they are extracting raw ore, and from these ores elements are releasing into the environment, and these are new for the soil microorganisms. These are also a type of pollutant but new for the microorganism. And microorganisms have no ability to decompose such elements which has been extracted from ore, from mines, from rocks, or during manufacturing of anything, these elements are going to release into the environment. These are also difficult to decompose. So from here we can talk again contaminants potentially amenable to bioremediation. So according to the bioremediation potential of pollutants by microorganisms, all pollutants has been categorized into four groups. Number one, readily degradable pollutants, somewhat degradable pollutants, and difficult to degrade, and generally recalcitrant pollutants. So all pollutants which are up to date has been classified according their nature to decomposition in environment has been classified into four groups. Most of the naturally occurring pollutants are organic molecules are readily degradable. Suppose fuel, oils, gasoline, ketones and alcohols, monocyclic aromatics, and bicyclic aromatics. These are pollutants are natural pollutants, and these have organic nature and are easily uh, amenable by bioremediation, are easily decomposed and degraded into their elemental form by means of by help of microorganisms, and somewhat degradable if you will see here, cerosot, coal tar, in other words we are saying charcoal, and pentachlorophenol, PCP. These pollutants are somewhat degradable. Microbes can convert into less harmful compounds by their metabolic and enzymatic activities, and these are difficult to degrade chlorinated solvents, TCEs, and some pesticides and herbicides that microbial communities have no enzyme and less rare enzymes to decompose certain type of pollutants, because most of these pollutants has been produced by human beings, by we can say by synthesized. This has been synthesized in industry at different environmental in different reactioning conditions. So these are difficult because when these are synthesized, the energy level is too high, where these bonds are formed, and microbial enzymes have no ability to break down such type of bonds, which require high energy. And some are generally recalcitrant. Recalcitrant are those pollutants which are unable to be degraded in environment. In such, we can take example of dioxins and polychlorinated biphenyls, PCBs. These are recalcitrant pollutants. These are non-degradable pollutants and living for enzyme in soil for longer time, and their life cycle and fate still not has been discussed and studied, because microorganisms are unable to decompose certain type of pollutants from environment. So we have to see one thing more here in this diagram, how pollution occurs on this globe, how such type of pollutants are going into environment. Okay, one thing we will see, residential area, they are digging to take groundwater for their homes. Okay, this is okay. Surface water, pond, lake, stream, and river. The sediments they contain from runoff, surface runoff. When there is rain, they take whatsoever elements and materials and compounds are present on surface of the earth, those are coming towards the water bodies, especially to lakes, to ponds, and to rivers, and sediment at their bottom. And some accidental spill, the leaking chemical tanks, some is going in vapor form to the environment, and some will be absorbed into the soil, and that will go automatically to the water bodies. If there is any leakage in underground tank, that will go into the groundwater near surface soil. They will go to the groundwater, and due to this, pollution is occurring at different layers, because human is going inside of the soil to store the different pollutants according for their safety nature. If due to any accident there is any leakage in such tanks, that is going into the soil and contaminating water body. So what will happen? This pollutant will go into this water, and this water will be used by this residential, the people who are living over here, and it will lead gradually uh, health consequences on those people. So how we can, such type of accidents are always happening on globe Earth, and how we can clean, and how we can adopt a strategy to remove or to clean certain soil. Because this is, whenever any pollution is occurring, that is a limited area that can be isolated, and that can be worked to remove pollutants from that circled and closed area. So any strategy can be applied over there. So what we have for certain pollutions, what we have biological approach to remove different pollutants. Suppose if pollution type is, if pollutant composed of hydrocarbons, we can use these type of techniques. We can use composting technique, we can use surfactants, we can use fungi, we can use plant, we can use fertilizers to remove that pollutant from that particular zone, particular soil region. And example of such thing is dibenzo, dibenzothiophene, toluene, phenolphthalein, carbazole, and octane etc. Such type of pollutants can be removed by this approach. Any of approach which is suitable, easy, and cheap can be used to remove those pollutants which having a nature of hydrocarbons. Okay, we are going for another group. Suppose if pollutant is halogenated organic compounds. So type of study we can, which type of approach we can use to remove certain pollutants? So we can use nutrient application to increase the microbial community to decompose certain pollutants. We can use aeration for oxidation, as well as increase the aerobic microbial population to decompose that pollutant. We can use bioaugmentation, we can use phytoremediation. These approaches we can use to remove pollutants from uh, soil if the pollutant have nature of halogenated organic compound. Examples: carbon tetrachloride, tetrachloroethylene, uh, trichloroethylene, PCBs, DDTs, etc. For certain type of pollutants, we can use these approach. Okay, if there is any soil where pollutant is herbicide or pesticide, so we can use microorganism to remove engineered microorganism to remove this pollutant. We can use bioaugmentation. We can use phytoremediation, because if we will grow plants over there, plant will gradually accumulate that pollutant in body cells, and we will use that plant for furniture and building materials. So pollutant will stuck inside of the plant for longer time. If metals are there, so the most suitable strategy is phytoremediation. Injection wells we can use inside of the soil, and constructed wetlands. We can make wetlands where microbial populations as well as plants will accumulate metals in body. Microbes will decompose, microbes will accumulate in body, and plants will absorb inside of the cell. Example: iron, lead, chromium, copper, lead, mercury, etc. And nitrogen compounds. If nature of pollutant have the nitrogens, so we can use phytoremediation, injection wells, aerations, ammonia, nitrate, and nitro aromatics, etc. For certain type of pollutants, we can use this activity and this strategy. So fundamental cleanup reaction. How microbes cleaning pollutants from the soil? So microbes are using such type of mechanism, aerobic metabolism. Microbe use oxygen in their metabolism to degrade contaminant. Suppose contaminant is present there, microbes are going to decompose that. So for that, they are getting energy from oxygen. They are using oxygen, and they are converting pollutant into less toxic form or elemental form. In anaerobic metabolism, microbes use a substitute another chemical for oxygen to degrade the contaminant. So microbes are using alternate of oxygen. They are not using pure oxygen. They are using alternate of oxygen to decompose the pollutant. Such as microbes are using nitrate, iron sulfate, carbon dioxide, uranium, technetium, perchlorate, etc. So microbes are using compounds of oxygen instead of oxygen. So such type of metabolism is called anaerobic metabolism. They are getting energy from this to decompose the pollutant from environment. So how they do? Electron acceptor. Suppose this is an item, they have ability to release an electron. This will, so this is oxidized. If someone is releasing any electron from its outer shell, so it is oxidizing. it is oxidized because it have removed one electron from its surface, and another electron and another atom acquired this electron, so it is reduced. So microbes are getting energy in terms of electron acceptor as well as electron donor. Okay, we can see here, please don't afraid from this complicated diagram. Just we have to focus aerobic biodegradation or aerobic decomposition. When an environment is aerobic and microbes are growing over there with pollutants, they degrade. How they degrade the pollutant? What they are doing? Electron transferred to oxygen as electron acceptor. One electron is going to transfer to this oxygen. Organic chemical benzene, one electron will be transferred to this oxygen. So what will be? It will form carbon dioxide plus H2O. Carbon dioxide, they will produce carbon dioxide as well as H2O. So this chemical benzene will be used by microorganism for energy. Due in result of that, microbial biomass will increase. Number of microbial cells will increase. If environment is anaerobic biodegradation, so what will happen? Electron will be transferred. Electron transferred to nitrate as electron acceptor. Okay. Here, here what they did. For this electron acceptor, nitrate has been used. Here was pure oxygen molecule, and here was a compound of oxygen has been used to transfer the electron from compound from organic chemical to nitrate, and it formed carbon dioxide, nitrogen molecule, and H2O plus microbial cells are grown over there. Microbial population is increased. So in both conditions, just they are breaking down the compound, breaking down the pollutant by taking one electron from it and transferring it to another molecule which is available over there. So some mechanism is used that is called co-metabolism. Is uh, co-metabolism scenario or phenomena is also used to decompose the pollutants from this globe. So in co-metabolism, what happens? Bacterium uses some other carbon and energy source to partially degrade contaminant organic aromatic ring compounds. So be clear over here. Bacteria use some other carbon and energy source to partially degrade contaminant. So how it happens? Suppose this is contaminant present in surrounding of the bacterium. Bacteria will use this contaminant and degrade and will convert into non-toxic, non-harmful condition. But for this, it use energy from starch and that converts into carbon dioxide and H2O. This is co-metabolism. This was natural metabolism, and at the same time, they used some energy and enzymes to convert this pollutant into non-toxic pollutant. In bioremediation, this phenomena is called co-metabolism. Here also we have to see, please don't afraid with complicated structures of the compounds. Just we have to understand one phenomena over here. Suppose this is benzene molecule, this is man-made molecule, this is pollutant, this is benzene. We know very well, we are using in laboratory every time this thing. Or this benzene monooxygenase enzyme is produced by microorganism in soil in presence of NADH. So what happens? That reacts with this enzyme reacts with benzene and removes one H2O molecule. one H2O molecule. By taking one oxygen from benzene, one electron from benzene to this and forms to NADH, forms H2O or NMDA. So the structure of benzene has been changed. Now it is less toxic. It is further fixed. Benzene peroxidase enzyme will be produced by another microbial population. These will add water molecule over here and the benzene structure change further. Benzene diO. It further will be changed by microorganisms into ketones plus NADH. NADH. Okay. And here this ketone is further converted by microbial enzymes into this structure, ketone dioxynate, hypothetical. And by microorganisms, again it has been broken down into more simpler form. Now, first it was in uh, this structure, in this hexagonal structure. Now it is structure has been changed, and now it is in linear form. So now it is not toxic. Now this is non-toxic. Its pollution effect is less now. So microbes can attack from any side and convert it into more and more simpler form. Similarly, if you will see the toluene, by microbial enzymes, it will convert into this form. Two OH molecules has been added. Now it is less toxic. Further, it will be reactive microbial enzymes. It is shape further will be changed. Okay, and at last it will convert into another form. It was the original form of pollutants, and by means of the microbial enzymes, these these has been transformed into less toxic forms, and gradually these will be converted into non-toxic forms and elemental forms. Similarly, if you will see here, this compound has been converted into this form. Okay, further this has been converted into this form by removal of chlorine. Okay, by removal of chlorine, this enzyme has been used in presence of oxygen. It is hexagonal structure. Structure has been broken down by removal of chlorine, and now these are two another compounds which are not toxic to the environment. So here we want to say only one thing. So in these two slides, just we want to say that pollutant which have a specific structure, and that pollutant is toxic in that particular structure. But when we are putting microorganisms together with pollutant, microbial communities, they are releasing enzymes, and these enzymes acting on the structure of that pollutant and converting that pollutant into less toxic form, and gradually by enzymatic cascade reactions it is converted into linear form or elemental form, and again it is used by primary producers. So we have to keep up to this slide. Just we are talking about the types of different pollutants and their nature in soil, how microbial communities are converting these pollutants from their strong toxic nature to less toxic or less harmful nature. Thank you very much. Have a nice time, please.